Assalamu alaikum. Today we discuss about this problem. This problem actually related to the power plant, and this is very important problem. And any job exam you can for prepare, you can understand, or you can understand this most important problem. Okay, let's start. This problem actually in this gas turbine. In this gas turbine is called the gas turbine. Gas turbine is working in Brayton cycle. Okay, Brayton cycle is given, and also there is the compressor and this Pascal pressure inlet. They're called the inlet compressor. This means they are the P1 pressure, and also temperature is the T1. Okay, and then the temperature is the T1, and the ratio we know obviously always will be the ratio is the P2 divided by P1. This ratio is called this. Okay, this and maximum cycle temperature maximum, which one can you guess which is called the T 900 degrees Celsius. Actually this one is the maximum temperature, so that's why it will be T3. Okay, if the turbine and compressor is have the if efficiency is the 80%, that means turbine and compressor both efficiency is 80%. So we can write a compressor and turbine both efficiency is the 80%. Okay, and also find the percentage of the actual cycle. That is actual cycle, because is the real and ideal diagram from we'll find out the actual, which is the actual efficiency we have to find out. At first we have to know what is the actual efficiency formula. Actually, efficiency, that means output by input. That means here output. Which is the output? This is the output. So our desire is the network divided by QE. This is the input. This is the mainly. Look, because sorry, network. Okay, network, and there network. What is the actual network? Network is a turbine work minus compressor work. Actually, that one is the network, and QE, which type of heat we have supplied here. Here is the turbine work we have to find out, and also compressor work we have to find out. But here it's work done, but we know this relation is related to the temperature. Here is the turbine and compression work, and turbine work if we consider turbine work, that means is a mass rate, and compression constant pressure, and turbine is a turbine T3 minus T4, right? And then compression work equal to this is the compression work mass rate and constant pressure, and T2 minus T1. And also another is the Qin, how much temperature is in this system, also mass rate and constant pressure, and here T3 minus T2. Okay, all is the common value is the mass rate, and that way we will cancel. Just will write the temperature T3 minus T4 and minus T2 minus T1 and divided by T3 minus T2, right? And this is the equation for actual efficiency. Okay, T1. Also know that T1 is given in the question. Also T3 is given. T3 is given. But we don't know the what is the T4 value and what is the T2 value. We have to find out. Okay. Okay. Let's just try. And here is the okay. Here is the we have to find out the T4 here from we have to find out the T4 and T2. But here is the conflicting point. Here is given the compressor efficiency and turbine efficiency is given. But here is all system is working with T and T1 divided by T2. Actually, we still T2 where we now we are doing in ideal condition. TS, because we have to we know this efficiency and this efficiency is 80%, but we don't know the what is the 2S value and what is the 4S value. 10% we don't know. We have to find out this. How, and after that we'll get this one, this T2. Okay, and from here we know the relation P1 divided by P2 in gamma minus 1 divided by gamma, and from here we'll get this one T2S, and T2S will get easily, and same time because it's the compression ratio. Yes, it will be inversely. This is the proportion 6 will be inverse. Okay, another is that we have also we have to find out the 4As. 4As. So we on the T3 divided by T 4S equal to T P3 P4, also the gamma minus 1 the gamma. From here, all easily will get the T4S. Now, this is the efficiency compression efficiency. The compression efficiency actually the what is actually the legal the output compression output divided by input, and output and divided by input is equal to output actually the T to S. Here is the T2S minus T1 divided by T2 minus S T2 minus T1 is the input. That means the component efficiency is the output. This one is output, this one is the output, and this one is the input. Okay, for efficiency of compression. Here all is known. This one we know 0.8, and this this one also we know from the here, and this one T1 also we know them from beginning is given question, and T1 also we know, but we have to find out the T2. From easily we'll get the T2, right? And another is the compressor is the turbine. Is the turbine. Turbine actually here also input and output is the here is the output actually the T3. Here this one is output T3 minus T4, and T3 minus T4S. From here we got this, and easily we get the T4, right? T4 will get easily, and then actual that is previous formula here in this previous formula we will put here. That means another again if I actual formula actual efficiency equal to we know that T3 minus T4 divided by T3 minus T2, and also here is the uh, uh, minus compression pressure by T2 minus T1, and after putting the value we will get the answer that will actual. Okay, I hope you have got this answer, got this point, and actually main target we have main target to efficiency. Actually, what is the actual efficiency? Because that one is actually in efficiency individual is given, and also this individual is given from, but we don't know 2As and 4As from, but T4 and T2 is they didn't keep, so we have to find out this from the output input. Here output input actually here output is the this one minus this one, and input is the this one minus this one. Okay, and for turbine is the input and output actually the T3 minus T. This is the output and input. This one is input. Okay, I have I think you have understood. Thank you. Thank you for your